Okay, welcome. This is video N10.3, actually the fourth video, as 10.2 got in two parts. So 10.3 we're going to talk about network verification and some more network terms. Specifically, we're going to talk about ping, how to ping, and use that as a tool to verify the network. Hopefully you'll experience that in the lab in Lab 10 on networking. And then we'll cover some additional common industry network terms. So ping is accessed through the command prompt, which you can get to by typing CMD into the system search window. This brings up a little dialog box, which actually emulates the operating system pre-Windows. So it used to be laptops ran on DOS, and the command prompt was a DOS prompt. So this goes way back to pre-Windows systems, which pre-1995, where they ran on DOS and there was a command prompt. So we get to this command prompt simulation at this point, and we want to use the tools there to verify our system with different commands like ipconfig. Look at this IP settings for the IPv4, which we talked about. We're going to talk about IPv6 as well. The subnet mask will be shown. We talked about the subnet mask in configuring our network adapter for our NIC card, and then we'll talk about the actual ping command. Okay, so if we get to the command prompt, it will be a very nondescript window, as you see here, black background, white text. It's actually a low-level interface to the operating system, and the command prompt you see here, C:\users / TL Stevens, my username, and then it's actually the greater than symbol. This is where the prompt begins, and I have typed in ipconfig and enter, and what Windows comes back with is the IP configuration. It shows me the Ethernet adapter, the local adapter, which we were adjusting previously in the configuration video. And you can see its IPv6 address shown here and the IPv4 address shown here. So we had adjusted the IPv4 local network adapter address for our NIC card to 192.168.1.200. And here's our subnet mask, 255.255.255.0. So the work that we did can actually be verified here. The IPv4 is the protocol being used essentially everywhere, except for at the highest level of service providers, network service providers like Comcast or AT&T. These are not enough addresses to provide IP addresses to everybody in the world. If you were to multiply this out, IPv4 is simply limited to 255 times 255 times 255 times 255. That's not very many. You can do the math, and we have millions and millions of IP addresses in the world now, and that's not enough addresses. So there's a movement underway, and has been underway for quite a long time, to transition to IPv6. And over here you can see my computer has an IPv6 protocol, and this is the address. And you can see many more digits. It is using hexadecimal again, so you see it goes to F. It goes 0 through F for each digit, and there are multiple, there are 4 digits in each group, and there's actually some groups missing here, because if a group is all zeros, you can omit it and just put colon colon. So if you were to multiply this out, it's a number that exceeds, we think, exceeds the possibility of all the Ethernet IP addresses in the entire world. So this is the long-term plan, IPv6. The short-term plan, and where we're at right now, is IPv4, and at higher levels, people implement IPv6 to create segmentation between IPv4 networks. The ping command, again, is a response to the command prompt. So here again is the command prompt with the kind of right pointing arrow. It looks like the greater than sign. I've typed in the command. It's an operating system command, PING, ping, and then the IP address of the device that I'd like to ping. So in this case, 192.168.1.10. So I was apparently trying to ping the MicroLogic 1400 in my Pinewood Derby controller to see if it was connected on the network and configured properly, and if it would respond. And so here we see the response. It's pinging. So we see the PC is trying to ping the device with 32 bytes of data, and then we see the replies. In 4 consecutive transmissions, it replied, and you can see it was sent 32 bytes. It took 3 milliseconds to respond. And so here's a summary of the ping statistics for that IP address. Packets sent, 4 packets, received 4, lost 0, round trip time, minimum 1 millisecond, maximum 3 milliseconds, average 1 millisecond. So it confirmed, yep, I'm connected, I can ping that device, and this tool is useful, like in the lab where some of the stations lost communications to the panel view. We could use the ping from the operating system to see, well, can the PC talk to it? Is it just a problem with Rockwell software, the RSLinks Classic or Enterprise, or is there actually a hardware issue going on? If I can't ping it, it's not going to connect to that device. Okay, and we're going to cover just a few additional industry network terms here. So Ethernet IP, we've talked about extensively. That would be the industrial protocol version for Ethernet connection. It's called the Common Industrial Protocol to Standard Ethernet, sometimes called CIP, the Common Industrial Protocol. This is actually governed by an organization called the ODVA, and I think this is a hot link, so you can go there if you want more information about the Open DeviceNet Vendors Association. So we talked about DeviceNet early in this series of videos. That was an early network that's rapidly going away in favor of Ethernet IP, but the same network committee that started DeviceNet is now working on Ethernet IP. The ODBA is that Open DeviceNet Vendors Association. Okay, OPC, I referred to in that topic discussion in RSLinks Classic, Open Platform Communication, and OLE, Open Linking and Embedding, are protocols for data transmission between devices. This goes back all the way to 1996. It is still quite prevalent in protocols. OPC UA is a unified architecture, and it's a way it has been adopted for machine-to-machine communications under the umbrella of the concept of Industry 4.0. And then DDE, again, I mentioned during the discussion of RSLinks Classic for dynamic data exchange, and this is how you can be compatible with things like Microsoft Excel spreadsheet and actually embed dynamic data in the spreadsheet that's being extracted from an Allen Bradley PLC, for example. And that's how the scoring system for my Pinewood Derby track works. It's a very elaborate, complex spreadsheet that does all the scoring and extracts the times from the timers in the Micrologix 1400. So if you want to do a simple data gathering out of a PLC, you can do it with an OPC DDE based topic, as we covered earlier. Okay, well that's going to be the end of this short video. The next video will be N10.4 on physical network. We'll get into the media, topology, and Ethernet switches.